cost estimation. Now, as you can see, in many projects, there are the three variables, right? If you recall them, the three golden variables: the specifications, the scope, time, and cost. They are constitute the so-called golden triangle. And any project manager would be very much concerned about getting them right, which means that they want to estimate the cost right, and plan the projects right, and do the right work so that they produce the specification. So getting this job right is very important thing for the project management in order to achieve project management success. So the learning's objectives. So after completing this lecture, you will hopefully understand the various types of common project cost, what constitute project cost. So when you want to build your estimate, what you should you should look into so that you build your estimate right. And there are the different forms also for cost. You have occurring cost, non-occurring cost, fixed cost, variable cost. So within each source of cost, you have also other subcategories of cost. So you will get some knowledge about that. And then you will learn also about the various methods of identifying the total costs and including the uncertainty. And at the end, we will look into a case study in order to see how a company really tried to manage the project based on one single success criteria, which is keep the project at minimized costs. So we will show you this case study and explain what the project organization has done in order to achieve this objective. Now in PIN2, he talks a lot and explains a lot about some mathematical models of calculating the what's it called, the learning curve and other mathematical forms. I thought they are not really very necessary. So I dropped them from my lecture, but you are welcome, of course, to read about them and study them on your own.
Are you dropping them from the exam?
Maybe. So, what if I may ask you at the beginning, what is, in your opinion, what is the difference between an estimate, creating an estimate, and making a budget? Have you thought about this difference? What is estimation and what is budgeting? What do you think? Anyone have reflected? Yes?
Estimation means that prediction of the cost which you might have, but budgeting is actually the amount you are putting in for project.
Yes, actually yes. So estimation is exactly what you need. This is what you would need. You calculate how many persons you have, how many machinery you need to do this work, how many this and that. And then you come up with this number, let's say 5 million. Right? But the budget could be less than this or could be higher than this. So the budget is what you actually get. In many situations, it should be higher than the real estimate because of the unexpected changes, unexpected events that could occur in your project. So you always, in addition to your estimate, you must have a contingency, managerial contingency and task contingency to compensate for eventual risk factors that may occur during your project. So keep in mind the difference between a budget and a cost estimation. Now, in project management literature, you will see that there are three different ways of defining your cost estimate. One of them is based on this we call system model, or Pinto call it the ballpark model. In this model, we don't really study the system we are going to develop. We look into just general characteristics, general features, and say, based on these features, this system will cost us this amount of money. For instance, in software applications, what they do, they say, okay, how many functions this software will produce? And they say 10, okay? And then they use some mathematical models to calculate how much it will cost them in man hours or in money to produce this system. And if you ask an entrepreneur to come and build you, let's say, a house or a garage, and he will ask you how many square meters you will have, how long it will be, what is the breadth, and based on this information, he will tell you it will be around $100,000. This is not a precise estimate. It is just a number you have to begin with, so that you can upgrade or make it better. This is what we call the system model or the ballpark. As you can see, the uncertainty of this system is very high. It's up to 30%. So you should expect 30% increase or less, of course, in relation to this model. The other one, we call it analog or comparative. In this analog or comparative, we have a project, a new project we are producing, and then we look into our database. We look for similar projects. Not exactly the same, but at least similar. And then we start comparing these two with each other. And then we use the base project or the source project as a reference when we develop the new estimate for this new project. This is called comparative. But again, here, because of different contexts, different risk factors, you have different people, different structure, right? The uncertainty is also quite high, as you can see, about 15%. But there is the third model, which is very exhaustive, time-consuming model, which we call it the analytical, or tend to call it the definitive. And as you can see, it has about 5% uncertainty. Here, we break down the project into our work packages, if you remember, from the work breakdown structure. So here, we actually use the work breakdown structure as a reference for developing these estimates. And as you can see, this is the most accurate. But if you try to look into accuracy versus estimation time, you will see that, for instance, that the analytical one is very accurate, but it takes a lot of time to produce that. So again here, it depends on how much time you really have for your project. What is the priority of your project? If the priority time, then maybe it's not a good idea to spend so much time on cost estimation, right? Because you have other priorities here. System models, as you can see, it doesn't really take much time. You just multiply two numbers. The number of square meters with a factor, the volume with a factor, the number of lines in a software system or functions with a specific number. And analogy also has less estimation time, but have a better, higher accuracy. When we use this, which one of these we should use? In which circumstances? You see, analog, its strength that you have a verified data, which means that your confidence level in this data is high. So you are more confident when you use this analogy approach. But of course, if you don't have similar project or similar experiences, it's very hard. And this is the most common method. System model is not reliable, is not precise, but we use it at the early phase when we are making prospect evaluation. Are we going to go for this one, or we shall wait, for instance? Analytical, this is very good when you are trying to develop a tender estimate. You want to come with a precise estimate so you can ask entrepreneurs, ask other contractors to come with a proposal, with an offer for you. So, but it is a very time consuming. Where shall we look when we develop our estimates? Here is like common sources. The labor, the people are doing the work. And you know how much the labor cost constitutes usually in any project? Can anyone give me a figure, a number? Labor costs, how much they constitute, they make up of the total cost estimate.
50%?
How much?
40%?
Actually, it's up to 80 to 90%. This is the highest contributor to cost in any project, is the labor costs. And that's why many companies, when they do, for instance, the fabrication or production, they do it in another country, cheaper country, because there they can save at least like 10-20%, and these 10-20% can make the difference for them. So this is the highest contributor to cost. And then comes the materials, and then comes other fees, subcontractors, which is actually a labor cost. And equipment, hiring equipment and facilities, and then you have travel and transportation. Usually, travel and transportation is around 5% of the total cost of huge projects. Now, within each category, you have also what we call types of costs. Like if we want to classify within each category, where can we further decompose these costs? Now, somebody says yes. Like you have something we call direct cost and indirect cost. Like salary to one employee, monthly salary is a direct cost. But then comes something we call overheads to that person. Overheads means that you come to your office, you switch on the light, it's warm, right? Somebody's cleaning your office, somebody is washing. All these are costs. So usually we add roughly around 30%, multiply the direct costs, multiply them with 40% and add them on the direct cost to come up with the total cost related to salaries, for instance. And we have something we call recurring costs and non-recurring costs. Recurring is something that you have to pay each month, each week, or each day, like salaries. But non-recurring is like a lawsuit. Somebody, you need to sue somebody, right? And then you just pay it only once. Or when you just pay a fine to a third party. And you have fixed versus variable. Salaries is a fixed cost. Variable cost is materials and equipment. They depend on each project. Some projects you need a lot of material, some others you need less material. But the people who will do the job, they have fixed costs, the salary. You will pay them regardless of the amount of the material you are using. And normal versus expedited, which means that sometimes you need to pay normal cost, salary cost per hour, but if you ask your people to stay overnight, right, then you have to pay them an expedited cost overtime. Or when you hire special people to do a quick job for you, they call expedited cost. So these are the cost classifications and some examples of direct, indirect, recurring, and non-recurring costs. It just helps you to have a better understanding of the common sources of costs and common under categories. But what we really should be more aware of is why we never get it right. Although we know what should be there in the costs, we know people are needed, we know material are needed, we know we'll travel, we know all that. But it's very unlikely that you get your cost estimate right from the very first moment. Or you should expect that during execution it will change and it will not be the same. Your original estimate will never be the same. And we ask why. Now, one problem is exactly this. When you start working on your project, because of this lack of understanding about the real scope of your work, you produce very low initial estimates. So your original estimate is wrong because of lack of your understanding. I will give you an example. Okay, and follow closely with me. Now, we have, let's say, a structure. And this structure is a riddle, actually. Okay? And it's component 1, 2, and 3. And this structure is located at station A. And you have one crane. Only one. So your resources are only one. And it's located here. And your task is to transfer or transport the entire structure to location B. But there are rules that govern this transportation. The rule says that you can only transfer one piece at a time. So you are allowed to go and pick this part and transfer it, let's say, to B. And you put it here. The second rule says that, so only one piece at a time. You can't take 1 and 2 or 1 and 2 and 3 and pick them because of load limitations. The second rule says you cannot, after you take 1, you cannot take 2 and put it beside 1 and then put it up. No, you can't do that. You can't have 2 blocks at the same station. Therefore, we have another station M, where you can put your 2 here, for instance. The third rule says that you cannot put a bigger block over a smaller block. The smaller block should be above the bigger block all the time, wherever we have. And now let's say the estimate, our estimate database says that it costs 100 kroner for each travel between the different stations from A to M, from M to B, and from B to A. And the question we ask you, did you understand the problem? You transfer, but there are rules. You can put a bigger piece over a smaller piece. You can't have 2 pieces at the same place. Just 1 piece and 1 transport at a time, 1 block at a time. And you have only 1 vehicle, and it's stationed at A. And each transport operation costs you 100 kroner. How much this project will cost you? Total? 700. 700. Are there proposals?
Do you pay for going between without?
Of course we have to pay for that because it needs benzene, it needs gas, some people need to work. Of course we will have to pay. So how much it will be? And it's located here at A. 900, yes.
1200.
1200. Last code. 3, 2.
14.
How many? 1400. First, okay. Actually, there are 1500 altogether. But this example illustrates that although it's sometimes it's mathematically a very clear problem, it's a transportation problem, right? But because of the question that you asked me, which is very relevant question, I thought it was a very good question. What we should include in this estimate? And in many cases, we forget essential parts of our estimates. We take some which are very obvious to anybody here. Anybody, when you want to calculate the number of operation, it follows this rule: 2 power n, right, minus 1. That's a typical transportation problem. But this one only calculates the number of transports when you have something on it. And that's why most of you said 7 at the beginning. Anyway, as you can see, the biggest problem actually, or one of the major problem in cost estimation is this initial estimate. It's usually not precise. People are in a rush to come up with an estimate. And let's say number 1. Now let's say we selected the right one, 1400 or 1500. So this is a good estimate. When we start the transportation activities here, things could happen, right? Damages could arise, roads could be blocked, waiting time could be a factor, and other risk factors, other technical risk factors that are there. We should also include that in our estimate. And lack of the definition. Actually, you said 1400 and I said 1500. It's because I failed to mention to you that after you complete all your transport operation, you will go back to where you started. And that's why it's 15 and not 14. But I failed to describe the entire scope of work. So part of the problem, you failed to calculate it right, and part of the problem because I failed to describe the scope of work exactly. And of course, underway, it might come a specification change. These specification changes could say, no, you are not allowed to use one vehicle, for instance. You should be using 2. Environmental consideration, right? Or you should, let's say, use another type of transport than this one, which may increase your costs. And there are always external factors that outside our control. Perhaps while we are driving, this driver gets hit by lightning, and then we will have to pay a lot of compensations and so on. So when we develop estimates, we have always to think about these problems. At the beginning, you start. Think about technical difficulties that could arise. Think about your original definition. Is it satisfactory, or is there something missing information there? Think about things, specification. New stakeholders come with new demands and new requirements. And at the end, there are always external factors beyond your control. Now, as you may have noticed, that there are always problems, either the initial or the technical or poor definitions upfront, or things change outside your control, or some external or environmental factor influence your estimates. So our goal, we want to come up with something, or an estimate or a budget that is good enough, that can be used actually for control, so we can defend our work. So the only way to do it is to allocate extra funds. And intend to distinguish between contingencies related to tasks and managerial contingencies. Task contingencies, they are buffers, reserves, some amount of money you allocate for each work package. And this amount of money is under the control of the project manager, which means that the project manager do not need to go back to the steering committee or to the project owner to use these funds. He or she can use them whenever they find it necessary. But there are another category of contingencies which called managerial contingencies. These are some sort of money, amount of money that the top leadership dispose and have. And they're only them who can use this amount of money. They use it, for instance, in order to cover big changes. Let's say if you change the contract type, right? If a major environmental disaster happened during your project. So this amount of money is used to cover the big things that they were not a part of your task at all. So the question we ask, how much contingency we should use? And let's only talk about task contingency and not managerial contingency. Some people, some authors, some experts, some project managers say one way to do it is just to have a ballpark, just a rough estimate. Says, well, you have, let's say, 4 work packages, you give work package A 10% extra. You calculate we need 5 million and then you add 10%. This amount of money should cover these unexpected changes. Some people say, okay, if B is another work package, but it's more complicated, right? It's more difficult, more uncertain, then we add more to it so that we are pretty sure. If B is easy, then we add 5%. As you can see, these numbers are not objective, not rational. They are subjective numbers. Could be, instead of 10, could be 15, or could be 20. So this kind of estimation might not give you the proper or the right budget, the right estimate. Might be too much, or even too little. In order to be more accurate, we use the PLO estimates. The PLO estimate says that for each task, for each work package, we define 3 different estimates. We define the so-called, the highest probable cost estimates. This is when you are very pessimistic. When things goes wrong, you say it will cost me this amount. This is the worst case scenario. And then you have something you also should know, or you should calculate, or you should find the most likely estimate. Like other projects achieve this goal or achieve this work package using this amount of money. Many of them did that. This is your most likely estimate. And then you have the outrageous estimate, the cheapest way of doing things. Because your estimate actually should lie between these 3 numbers. It is somewhere there. And then we use statistical methods, for instance, beta distribution, and we use this beta distribution in order to find out what is the expected value of your estimates. How much, if we look at the normal distribution table, you know, this is your estimates. It's usually like this. It's not symmetrical, right? The normal is not symmetrical. So we try to find out where is your expected value. This is your most likely, and this is your expected value. This is the cost, which we call it the one which is in the middle of the normal distribution table. And the difference between these 2 values, statistically, they define the task contingency. So if you want to know what should be your task contingency, you calculate or you add all the most likely cost, and then you calculate the expected values, and the difference between them gives you the task contingency. This is the amount of money you, as a project manager, should have extra. But then some people ask, how much money we should add on top of that so that we become even more certain that the project will deliver within this cost. Then we use this variance or standard deviation. We say, well, we want to be certain, like that. We are very happy always if we can reduce it below. So we want to be certain this amount. This is our certainty region, which means that in addition to this estimate here, we have to add something extra. And if your goal, let's say, you want to be able to be confident 95%, which means if you want that the probability that your cost estimate will suffice for your project with a 95%, then you must find out how many standard deviations you need to add to your cost estimate. And then you should find the variance or the standard deviation. And here it will tell you how many of these standard deviations are needed to add to your base estimate, right, in order to find out this managerial contingency to make you confident in your project costs. So here are some statistical methods. I assume that most of you have taken statistics before, right? You know that. You know how to find the expected value, and you know how to find the distribution, and you know how to find other data. And if you know that, the calculation is very simple. Just remember that the difference between the most likely estimate and the expected value is what we refer to task contingency. And if you want to add more in order to be even more certain, you should find out how many standard deviations you need to add to your cost estimate in order to make sure that your project will be 95% certain, or 85 or 70 or whatever. By the way, if you want to come up with 95% certain, you will go to this normal distribution table, and look where we get the 95%. And it is around 2 standard deviations. So we calculate the standard deviation and multiply it by 2, give us a number, and this number we add it to this expected value, then we are 95%. But I guess you are experts also on that, so no need to use much time on statistical analysis. Maybe in the last lecture, when we go through perhaps one assignment from before, then we will illustrate that in a better way. But what really I want you to learn now is the managerial part of that. We know that cost is important. We know the cost component. We know that your estimates cannot be accurate. And we know things change. But one thing also we should know is how to manage projects that have cost as one important success criteria. What should we do if you are a project manager and you got this task from your superior saying to you, we have a problem. This cost or this project has gone like terribly overrun. And your task now is to go in and do something about the cost. What shall we do? How should we think? So this is a project that took place in Canada in 1996. It has to do about developing a very complex facility, something Union Carbide, Premier Technology. They want to produce a byproduct of oil and gas. And the prime requirement of this project is to keep the cost at minimum costs. Because at the beginning of this project, after 6 months, they discovered that the technology they were basing the entire facilities on was outdated. So they decided to change that technology, and changing that technology requiring changing the design, changing the specification, and then the cost or the budget went totally wide. So they decided now we should rethink the entire thing, right? And we need somebody to come and help us to keep the cost as minimum as possible. So minimize cost. So what the project organization has done? Well, they decided that they have to establish some important success factors. Again, if you remember, when you have success criteria, you must reflect them. You must operationalize them through the use of success factors and some concrete measures that has to be implemented in order to achieve your success criteria. And as you can see, the goal is to minimize total cost. Save me as much money as possible. So what are the major success factors this project organization has established? Number one, as you can see, you should align this philosophy, align this strategy not only within the project organization, not only with the sponsor organization, but they said that every contractor, every subcontractor, every driver should be aligned to this idea. So alignment. And what they did in order to ensure the alignment, involvement. They had weekly meetings where their focus were how can we do that? What can each one of us do so that we reduce the total cost? So again, if you remember, I told you this term alignment is very, very important. You try to tell people, involve people, inspire people so they agree on measures that would produce your objectives. And then they said, in this project, we have to plan upfront a lot of things. We cannot sit and wait and solve problems. We cannot do fast tracking, because with fast tracking, things can go wrong. So they based this project on very, very, very good plans, very early plans. And again, they were very good and very clever to identify all the risks associated with this plan, and they also were very clever to address all these risks up front before they can actually occur. And in addition to that, they thought total quality management. Don't do a shit before everything clear and present and available for those people who are going to do the job. Don't let them sit there and guess, because guessing, right, requires time, and time is money. So these are their philosophies. So let's look a little bit closer on what they did, little bit more concrete. As I told you, involvement. They had to think about all the people who were involved in this project, and they had weekly meeting with them, and in some situations daily meetings on that with them to enforce this idea. And they took into use this early planning. Now this project was conducted in Canada and in Alberta, Canada. And you know, in this part of the world, it can be very, very cold in winter. In winter, it can be like minus 40 degrees. And the road regulations in this country says that you cannot transport heavy equipment all the year around. You can only transport your equipment, heavy equipment, only in the period December, February. And this piece of information was very, very important for this project group, which means that all the huge equipment that needed for fabrication or the parts that they will install at the site should be transported only within this window of time, these 2 months. And they couldn't wait more time to transport because it wasn't allowed. So what they do? They had to order these equipment at a very early stage and making sure that the transport only will take place in that particular window. And daily follow up on these activities. Another thing they did, rather than, building everything on the ground, on the field, they looked into standardization, prefabrication, and pre-assembly. So they did everything somewhere else because the temperature at this place was very, very high. It's not high, the opposite, very, very cold. And a lot of operations they couldn't do during the winter time or the fall time. So did a lot of prefabrication. And in order to do that and synchronize it with this transport activity, they had to make detailed planning for that. The overall cost savings from these measures were about $2.5 million. Just thinking like that and doing that. And again, the risks. It's very cold, so they thought that we had to be above the ground before December, so that the equipment can come and or the other parts can come and be installed. So out of the ground detailed plan was developed before the winter struck. Again, heavy planning. Transport was done on the right time. Risk assessment, this kind of way of thinking, saved the project around $3.5 million. And then total quality management. It's about, the idea is that we should be, before we implement any plan, every document should be available. Every description should be available. We shouldn't leave any room for guessing or any room for assumptions. Many existing work processes were analyzed, documented, restudied again to make sure that, or to look for places where they can reduce costs within these work processes. And this total quality management, their focus all the time was cost. They looked into how to enhance field productivity. They say that each 1% improvement will save you $500,000 in savings. So they did, for instance, things like management of overtime. Shouldn't be too much of that because it's more cost. They have also worked on just-in-time staffing and de-staffing. People were sent at the right moment and were taking out at the right moment so that they enhance the productivity. And the minimization of this winter work, because there the productivity is very, very low. It's very difficult to work on outdoor project when the temperature is 40 degrees minus. But they did the transport within this period. And the bottom line of this project is net savings of 10%. Actually, they managed to save 10% of the original cost estimate. The original cost estimate of this project was $350 million, and they managed to save $35 million. And one of the things actually they were using is this incentives. They gave money to the people who were doing the job. Money were also given to the people, the entrepreneurs or the other contractors. So although they had a lot of incentives, yet they managed to save almost $35 million. Because they had one focus, cost. looked into single aspect in their project. Where can we save these costs? How can we save these costs? What is needed to save these costs? And as you can see, it's good plan, good risk management, good quality management, alignment. These are the key words for success in any project. Questions?
Yes. In the initiation phase and planning phase, which seems to be the focus here, how long did that take? How much percentage of the full project time was spent on initiation and planning? Since
Yeah, I think the number I remember is like 3 months.
3 months?
Yeah.
Or more?
Yeah, something. Now, in the planning phase, initiation phase, like finding out what are the documents needed, how we will go about all these design, preparing all these documents. But I will check the number again and I will give it back to you. But they use time on this planning phase.